Okay, so let's look at a radical. A radical looks like, like a square root or some kind of root. Okay, so let's talk about what these parts are called. This part that's inside is called the radicand. So the part that's inside the radical, we call that radicand. And the root, or how many roots we're supposed to take, this we call the index. Okay, so I'm going to check to see if you understand. Let's look at number 1. What number is the radicand? 16, good. Trick question. What number is the index? 2. Okay, if there's nothing, it's known that it is a 2. Okay, not a 1, it's a 2. So square roots are all second roots. Okay, what is the answer for this one? Is it plus minus 4? No, it's just 4. Okay, so this is a little bit tricky. All right. Square root 16, it is known that there is an invisible plus sign on the outside. So this is just 4. When will you get plus minus? If you have an x squared equals 16, and you have to solve for x, the question is, what x value will, when you square it, you get 16? 4, but also minus 4. Right? Because if you square a negative 4, you also get 16. If you square a positive 4, you also get 16. So these are two very different problems. If they have a square root with nothing outside, it is just understood that there's a plus sign. And then you just take the positive root. Yes? No? Okay, so if they put negative square root 16 like that, the answer is negative 4. Not plus minus 4. Yes? Okay, so this is called the principal root. Principal root means you take the principal root, which is if it says plus on the outside, you put you just leave it as a plus. If it's a negative, you just leave it as a negative. All right. Let's look at this question. Cube root of 0.008. What number is the radicand? 0.008. What number is the index? 3. Okay, we're going to try to use our calculator for this. That way you know where the cube root button is on your calculator. So locate the cube root button or the x root button on the calculator. So I'm going to tell you the answer is 0.2, and you're going to just try to get familiar with your calculator to make sure you actually do get 0.2 on the calculator. So we've got to practice with our calculator to make sure that we know how to use it before the test. So try it. If you cannot get 0.2, let me know. I will help you on your calculator. Okay, so now let's try these. 1, 2, 3. Find the real root of each number. Number 1, square root of 0.04. What's the answer, everybody? 0.2. Number 2, cube root of negative 8. Negative 2. Okay, this is just the principal root, so it's just negative 2. Number 3. Square root I. No solution. Yes, it's probably square root I, but then this wants the real root. So the real number part. There is no real number part, so no solution. All right. What is the simpler form of each radical expression? All right, square root of 4a squared. Okay, if you're not really sure how to do this, what you want to do is split the square root. So if anything inside in the radicand that is multiplied, you can split it like this. If it is multiplied. If it's added, subtracted, no, you cannot do that. If it's multiply, you can split it. So square root of 4 is what? Square root of a squared is a. Yes? You guys know why square root a squared is a, right? Okay. All right, next. Square root of 16x to the 8th. All right, square root of 16 is 4. Square root of x to the 8th. X to the 4th. Okay, so if you cannot see that it's x to the 4th, so basically it's saying like which one doubled is going to give you x to the 8th, because this is a index of 2, right? So that's going to be 4 doubled. Now, if you cannot see that, there's another way of doing this. That may be a little easier. We're going to spend one section on it, but right now I'm just going to kind of give you a trick to do your homework a little faster. You can write this square root or any kind of root as a fractional exponent. So what you do is you take the radicand that's inside, you put the exponent as a fraction, but the numerator. The index is the denominator. For example, square root of 2 to the 4th. Square root of 2 to the 4th. What's the index on this square root of 2 to the 4th? 2. Okay, so we can change this as 2 to the 4 over 2. What the power that's inside the radicand is the numerator. The index is the denominator. Okay, so now we can simplify this as 2 to the 2nd, which is 4. Okay, so this might make some of the homework problems a little easier because you can change it to a fraction and simplify it. Okay, so let's try it. Number 3, cube root of a to the 6th, b to the 9th. If you don't know how to split it up 3 ways, you could do the fractional exponent, so try that. All right, what you guys get for number 3? A what? Squared? B cubed. Good. All right, so try number 4. Okay, what you guys get for number 4? X squared y. All right, now there's a problem. Number 4. We want the principal root, right? So that means we want what kind of number? Positive or negative? Positive, because there's a invisible plus sign, right? So for the number y, or the variable y, can y be a positive number? Yes. Can y be a negative number? No, y cannot be a negative number because we want just the positive outcome, right? So what can I do to make sure y is always positive? Yeah, I have to put absolute value around it. I want the answer that comes out to always be positive, but there is a chance that y could be negative, so then I gotta make sure that it's always positive. What about x? Can x be a positive number? Yes. Can x be a negative number? Yes. X can be a negative number. Why? Because it's squared. The answer is squared, so it doesn't matter. It's always going to be positive. Yes. Okay. Let's look at this one. This is a little bit tricky. I hope I can explain this a little better than first period. What is the index on this radical? The index on the radical. Cube root, so 3, right? Odd roots are a little bit different. Odd roots If it comes out positive, it comes out positive. If it comes out negative, it comes out negative. We don't need absolute value. Okay, so here's the rule. You need to put absolute value around the root if n is even. If it is odd, meaning the index is odd, you just don't care about it. So I am going to give you a few scenarios here. Okay, index. Odd, even. If you have an odd index, you just don't care about the absolute value. It is what it is. It comes out whatever sign it should come out. Even, there are two cases. I'm just going to give you two cases. Square root of x squared is what? X. Square root of x to the fourth is x squared. Which one needs absolute value? X to the first. So if it comes out and it has an odd exponent, it needs an absolute value. So if it has an odd exponent, needs absolute value. Yes. Basically, it's all the ones that have an even index that has a problem because there's a chance it will come out as negative number. Then you need to make sure it does not. All right, so let's go back to our previous problems and check which ones we need absolute values and which ones we don't. Okay, so let's look at number 1. First, check index. Is the index odd or even? Even? Okay, now check the answer. Is there any exponent that is odd?
Yes.
Yes. A is to the first power, right? So does it need a absolute value? Yes. Because we don't want A to be negative. Okay, number 2. Is the index odd or even? Even. Okay, now look at the answer. Is the exponent odd or even? Even. Does it need an absolute value? No. Okay. And then number 3, is the index odd or even? Odd. Odd never needs an absolute value. And then number 4, we already did. Okay, let's have you try 1 and 2. Number 1, what is the answer? 9x squared. Does it need an absolute value? No. Okay, number 2, what is the answer? A to the 4th. B to the 5th. Does it need an absolute value? How many people think it needs an absolute value? How many people think it does not need an absolute value? Okay, it does not. Why not? The index is odd. It's very tricky. Okay, next. Let's multiply these radicals together. So the rule is you can only multiply or divide radical expressions, if they have the same index. So you have to make sure they have the same index first. So let's look at number 1. Can I multiply number 1 together? No, can't do this. So 1 has an index of 3, 1 has an index of 2, cannot multiply. Number 2, can I multiply them together? Yes. Okay, so what you do is if you can multiply them together, you just multiply the radicand. So cube root of -8. What's the cube root of -8? -2. Number 3. Can I divide?
No.
Do they have the same index?
Oh, yeah.
Yes, so I can. So I'm going to just put them as one big fraction under that radical sign. And I'm going to just divide. So 18 divided by 2 is 9. X to the 5th divided by x cubed is x squared. Okay, what's my answer?
3x.
3x with absolute value. Because the index is even, it comes out as an odd exponent. All right, try number 4. Actually, let me do this with you. Index, sorry, can I divide them? Yes. So this is the cube root of 162y to the 5th over 3y squared. 162 divided by 3 is 54. And then y cubed. Can I cube root 54 evenly? No, I cannot. And please don't use your calculator and get me decimal. We don't want decimals. We want to be able to just simplify it. All right, so cube root of 54. Okay, so basically we're looking for something that has 3 of a kind that can come out. 54 is what times what?
3 to the 4th.
No, it is not 3 to the 4th. Huh? Just give me 2 numbers that multiply together to get 54.
9 and 6.
9 times 6. Okay, we want to do factor tree. So do factor tree if you cannot figure it out. But factor tree sometimes is too slow, so hopefully you don't do that for the entire chapter. But if you cannot figure it out, of course, do factor tree. Okay, 9 is 3 times 3. 6 is 3 times 2. So what you want to do is get it all the way down to the prime numbers. Then you look at which ones have 3 of a kind. That comes out. Depends on the index. If the index is 2, you look for 2 of a kind. If the index is 3, you look for 3 of a kind. Okay, so this becomes 3 comes out. 2 stays inside. And then there's a cube root. Make sure the index stays on there. What about the y? Y cubed. It comes out as y. Does it need absolute value? No, because it's an odd index. All right, let's try it. Let's have you, number 1 is kind of easy. So let's try 2 and 3. Okay, let me know when you're done with 2 and 3. Okay, first of all, check the index, make sure we can multiply, which we can. It's much better if you don't multiply the numbers together. Okay, now do factor tree. 72 is 8 times 9. 8 is 4 times 2, which 4 is 2 times 2. 9 is 3 times 3. 10 is 2 times 5. Okay, so anytime you have 2 of a kind, it comes out. So that is 2 comes out, 2 comes out, 3 comes out. Okay, so that's 2 times 2 times 3. 2 times 2 times 3. 5 stays inside. All right, x to the 4th. X to the 4th, there are 4 x's, so 2 of them come out, and that is x squared. Y to the 5th, there are 5 of them, 2 of them, 2 of them, 1 stays inside. Oh. Okay. Sorry, let me just finish this one. Okay, no absolute value on this. And let me give you the last one just so you can check.